Welcome back, mathematicians. In this lesson, we're learning how to find the zeros of a function and the y-intercepts. We're going to start out by talking about what zeros and y-intercepts are and looking at the graph in order to be able to find them. But we're very quickly going to move on to equations. We'll start with a basic equation that's very easy to plug 0 in and find the zeros and the y-intercepts. But we're going to move on to complex equations such as solving absolute value and also cubic and quadratic factoring. Let's get started with the graph. First of all, let's talk about what a zero is. Now we say the zeros of a function, and what we mean are solutions to the function, where y is equal to 0. This is going to be where it crosses the x-axis, and so technically a 0 is also an x-intercept. You might also hear it named solutions. Let's write that down here as well. To find it graphically, it's pretty easy. We're just going to look at the graph exactly where it crosses the x-axis, and that's going to be our solutions. So in this case, there is a 0 at -1, and there's another one at 3. This is considered our solution set, and we use the curly brackets in order to indicate our solution set. Now let's talk about y-intercepts. A y-intercept is where it crosses the y-axis. And if you look at our coordinate plane very closely, that's actually where x is equal to 0. Here's x, here's where it's 0, so this is the y-axis. Graphically, it's quite easy. We can simply look to see where it crosses the y-axis, which is right here, at -3. So our solution set is a single y-intercept. In this case, 2 zeros and 1 y-intercept. Now let's go ahead and see how we can solve this algebraically. I'm starting with a very basic equation so that we can understand exactly how to find zeros and y-intercepts. So remember that a 0 is where the function crosses the x-axis. So it's technically an x-intercept. Functions cross the x-axis when y is equal to 0. So in this case, we want to set our function equal to 0 and solve. We're going to do that by setting the whole thing equal to 0 with 2x plus 1 on this side. We're going to start by subtracting 1 from each side and then dividing by 2. So our x is equal to -1/2, and that makes our 0, or our solution where it crosses the x-axis, -1/2, and we have 1 0 to this function. Now let's talk about y-intercept. Y-intercept is where it crosses the y-axis. Remember that it crosses the y-axis when x is equal to 0. A good way you can remember these is that they're opposite of each other. So we're actually going to evaluate this by plugging 0 into our function everywhere that we see an x. That means we're going to have 2 times 0 plus 1 right here. So this is 2 times 0, which is 0, plus 1. And so our y-intercept is 1. And we have a single y-intercept. Now, I don't want you to forget why we're doing this. We're doing it algebraically so that we can find things that might be fractional or not perfect. So if we put this function into a graphing calculator, whether that's online or a calculator that you have in your hand, we can check to see that we have algebraically found the correct solutions. Now, I don't recommend that you start by putting it into the graphing calculator. You need to practice doing it algebraically because, of course, if it's on a quiz or a test, you're going to want to know how to do this, and then this is a way that you could check it if you have access to a graphing calculator. If we look at the graph of here, we can see that 0 is crossing at negative 1/2. So that's our 0. This is the number 1, and this is halfway, and so we've gotten this one correct. If we look at our y-intercept, that's where it's going to cross the y-axis. You can see that here is the number 1, and so this is also correct. So it's very tempting to go deep into algebra. Sometimes the algebra is so much easier than remembering that we have a graph. But don't forget that we're doing this so that we know where it crosses axes on the coordinate plane. So now let's try one that has an absolute value equation in it. Before I begin, I just want you to know that this is an entire lesson onto itself. Knowing how to solve absolute value equations is a skill that you might want to practice if this doesn't look familiar. I'm going to go over it a little bit here, but I'm not going to do it in much detail. I'm going to assume that you already know how to solve absolute value equations. So if you're unfamiliar with this, you might want to pause at this point and go find my video on solving absolute value equations and practice that a little bit before coming back here. So I used a little movie magic to move that up out of our way, but not get rid of it, just in case you need to know what to search for. So first we're going to find our zeros, and we're going to give ourselves a little bit of extra space. Don't forget that zeros are where it crosses the x-axis. It is the x-intercept, and that's where y is equal to 0. In this case, we are then going to set f of x equal to 0, and we're going to solve. So we have 0 equals negative absolute value of x minus 5 plus 3. The first thing I want to do is move that 3 to the other side by subtracting it. Now I have negative 3 equals negative absolute value of x minus 5. If the absolute value was alone, we would know that there are no solutions in this case, because we can't have an absolute value equal to a negative number. However, we have a negative in front of the absolute value as well, which means that we can handle this in a couple of ways. We could divide both sides by a negative or multiply both sides by a negative. I'm going to choose to multiply both sides by a negative. It turns out to be exactly the same. Negative 1 times negative 3 makes a positive 3, and negative 1 times that negative that's inside the absolute value makes the absolute value positive as well. Now we're going to do the work of absolute values. Remember, to get rid of an absolute value, we end up with two equations, x minus 5 equals and x minus 5 equals. One of the equations is equal to the positive version, and one of the equations is equal to the negative version. And so this is how I end up with two solutions. In order to solve, I'm going to add 5 to both sides, and this solution is x equals 8. I'm going to solve it the same way, but you'll see because that's a negative 3, this solution is actually 2. And so my solution set is 2, 8. I am intentionally putting this in order from least to greatest. And let's go ahead and move this over a little bit so that when we look at our graph, we have lots of room. Now we need to find our y-intercepts. Remember, our y-intercept is where it crosses the y-axis, and it crosses the y-axis when x is equal to 0. So in this case, we are finding f of 0. We're going to put 0 in everywhere that we see x. So I'm copying my equation down, and instead of x, I'm going to put 0. In this case, that means that inside the absolute value, which I have to do first, I have 0 minus 5, which is negative 5. Now this is where a lot of students make a mistake because there's a double negative here. So we have to evaluate the absolute value first. The absolute value of negative 5 is positive 5, but this negative on the outside doesn't change. And so now we have negative 5 plus 3. So our f of 0 is negative 2. 5 negatives and 3 positives. So we have one y-intercept. Let's go to the graph to see if we're correct. Now it's a little bit of a mess, but we can see that our zeros are at 2 and 8 pretty clearly. 2 and 8. And if I move this graph over just a little bit, we can also see that our y-intercept is at negative 2. So this is a fantastic way to ground yourself back into the work that you're doing and also make sure that you've done it correctly. Now let's tackle this cubic equation, which actually has a hidden quadratic inside of it. So before I begin, after we do a basic factoring job, we're going to have a quadratic inside of here to factor. If you are not familiar with factoring quadratics, things that look like this and then get factored to this. A lot of times students don't know exactly what this is called, but you either know you can do this or not. If you are very unsure about this, you are going to want to look at my factoring quadratics video, get a little bit more familiar and do some practice, and then come back here. In this case, you're going to search for factoring quadratics. And we can go ahead and do a little bit of movie magic to stick that up in the corner. Now let's get down to the business of doing our zeros. Once again, I'm going to remind you that zeros are where it crosses the x-axis, which means that our function itself is set equal to 0. This means we're going to put 0 where f of x is and copy our equation down. Now, as I'm copying this equation down, I'm noticing that there is an x in every single term, and that this is not factoring a quadratic right now. Right now, it's a cubic. So I realize that I can actually take an x out of every single term and do a greatest common factor first. That's going to leave x squared here, minus 6x here, minus 7. Now I have a quadratic that I can factor, but when I go to factor this, I can't forget that I have an x in front of the entire thing. I'm going to factor this into two binomials, and the easiest way to start is just to put x in both places. Off to the side, I am going to work with the number negative 7. Now there's lots of tricks for figuring out how to factor this, but I'm going to look for negative 1 and 7, 1 and negative 7, and that's it because it's a prime number. I know that this has to add up to a negative 6 in the middle, and so I'm going to choose this because a positive 1 and a -7 are the only thing that make -6. Now, if that's a little confusing, like I said, remember, go solve some quadratics before coming back here. Now we have to figure out how to find this solution. To find the solution, we need to realize that if we plug 0 in any of these spots, it's going to make the whole thing equal to 0. So what we really have are 3 different equations to solve. X equals 0, x plus 1 equals 0, and x minus 7 equals 0. X equals 0 is already solved. So I know that that is one of our solutions down here. In this case, I can subtract 1 from both sides, and I'm going to get x equals -1. Let's bump him up for a little more room. Here, we're going to add 7 to both sides. So we get x equals 7. So my solutions, put in order, are -1, 0, and 7. And so for this function, I have 3 total zeros. Now let's talk about y-intercepts. Y-intercepts. Remember that that's where the function crosses the y-axis, which means that we're setting x equal to 0. So we're finding f of 0. In this case, f of 0 is a lot easier to find than when the whole function is set equal to 0. We're going to put 0 in for the first x, and you might already be seeing the pattern. 0 in for the second x, and 0 in for the last x. Since every single term in this cubic had an x variable, it's going to be 0 minus 0 minus 0. So our y-intercept is exactly at 0, and we have one y-intercept. Now remember, it's always good to go plug it into a graphing calculator. I've used Desmos in order to plug all of these in, and so we can look and see if we have it correct. Now I've zoomed in a little. You're not going to be able to see the bottom of this side of the graph, but we are going to be able to see whether or not we have all of our zeros correct. So you can see that for the x-axis, our 3 solutions are -1, 0, and 7. And that is exactly where they're crossing the x-axis. So those are our zeros. Our y-intercept, you can see, also goes through 0. And so our y-intercept is also correct. I hope that's helped you learn how to find zeros and y-intercepts. Don't forget to like or subscribe below and put things in the comments if you have any further questions.